Welcome to Transoff Solutions video, highlighting Nexus, our newest and advanced intersection design software. Six powerful functionalities of Nexus give the designer the ability to develop high-quality and safe engineering intersection designs in a fraction of the time it normally takes. In this demonstration, we will be using Nexus to design an intersection with the given right-of-way and building constraints, as seen in this satellite image. This next slide shows the final design layout created using Nexus. The video that follows will show you how Nexus can be used to configure this design. We start with the horizontal alignments of both roadways, which can be created using any geometric tool, including vertical CAD platforms such as Civil 3D, GeoPack, or Inroads. We have also predefined the vertical profile for the east to west roadway. The profile for the north to south crossroad, as well as corner alignments and profiles, will be designed later using Nexus. We then use the Generate Intersection tool in Nexus, and then select the road alignments and the relevant intersection template. Upon selecting the relevant intersection template, we then apply it to the proper orientation by rotating it to suit. Left turn storage bays, based on capacity analysis data, can now be modified as required. Note how the left turn bay tapers are automatically generated for the east to west approaches. Next, we will design the corner geometry based on the appropriate design vehicle. We do this by first selecting the design vehicle, the right turn movement, and the appropriate speed or turning radius. With the resulting inner tire track and using the triarc method, we then calculate the best fit geometry. If needed, the values can be refined. The outer tire track governs the slip lane edge of the corner island. We can also specify geometry only by specifying the corner radius and the entry taper. Using the corner geometry tool, each quadrant can be quickly configured. Next, using the control radius, we will specify the left turn design movement with the appropriate speed and turning radius. The Govern Median Nose tool is then used to set the median nose and the stop bar and crosswalk markings in relation to the swept path. The next group of tools deals with the dynamic editing capabilities. We will first add bike lanes on the entry and exit sides on the south leg. Then we can use the Edit Lane Configuration tool to adjust the lane group, in this case, increasing the lane width for the right turn lane. Next, the crosswalk can be relocated without difficulty. Once all legs are edited, we can evaluate the sightlines for this intersection. Sightline tools include departure sight triangles, dynamic left turn sightline analysis, and critical point sightline. Departure sight triangle for the left turn is checked. Applying the dynamic major left turn sightline tool to the northbound left turn, shows that there are no sightline issues, as the northbound left turn movements are staggered. Next, we will look at the Design Grading tool. As noted previously, the east-to-west road profile has been predefined. We will focus on the north-to-south road. VPIs can be easily added and vertical curves can be defined based on k-value or curve length. You can also drag VPIs as needed. The next tool is the Corner Region tool. This shows all the cross slopes between the main alignments and the corner alignment. The red zone is indicating the cross slopes are greater than 4% in this case. By adding a high point and a low point, the issue is resolved. By using the Add Cross Slope Region feature, different grading models can be configured. For example, if we add a cross slope to each corner region, we can configure a grading model where a cross slope is maintained on the through roadway, in this case, the east to west road. The vertical profile of the crossing road shows this. Once all corner regions are defined, you can export alignments as land XML and import it to vertical CAD platforms for continuing the design.